we continue looking at matrices, and you remember that this is the inverse of a matrix. Matrix ABCD, the inverse is 1 divided by AD minus BC, which is 1 divided by the determinant. And that is multiplied by the augmented matrix. D minus B minus C A, where you interchange A and D, change the sign of B and C. Now, what we want to do is look at the proof of this. All right. Now, how does the inverse of this matrix becomes all of this over here? Let's see. So, what we have here is A, B, C, D. You see that? Now, you remember that when we multiply a matrix by its inverse, what we get is the unit matrix. So, you multiply this by the inverse. What you get is 1, 0, 0, 1. All right. Now, this inverse, it is a matrix. This is a 2 by 2 matrix as well. So, I'm going to say you multiply it by, let's say, you have, this is A, B, C, D. Let's say these are E, F, G, H. The question is, or the questions are, what is E equal to? What is F equal to? What is G equal to? And what is H equal to? We need to find those things if we're going to find the inverse of this matrix. Now, what we're doing is looking at the proof. I've now seen a past paper question where they ask you to prove the inverse matrix formula, but we just have some fun proving it. Now, here, if we are going to multiply these two matrices, remember, it's row by column. So, you multiply A by E, and what you get is AE plus, you multiply B times G. So it's BG. You remember? It's the row 1 by column 1. Multiply the first elements together plus, then multiply the second elements together. And that is equal to 1. Good. Now, this 0 here, right here, it is in row 1, column 2. So you must multiply row 1 by column 2 now. So when you multiply that out, it's going to be AF. So you have AF plus BH. B times H. You see that? A times F plus B times H. Nice. and that is equal to 0. Now this 0 here is in row 2, column 1. So we must multiply row 2 by column 1. So multiply the first elements, that is CE. CE plus row 2, column 1. The second element is multiplied is DG. So it's DG, and that is equal to 0. Okay. Then this 1 is in row 2, column 2. So we must multiply row 2 by column 2. So the first element is multiplied, CF. So that is CF plus, then the second element is multiplied, DH. So that is DH. And all of that is equal to 1. Okay, good. Let's look at these. Remember, what we want to find are E, F, G, and H. Suppose we transpose, let's say this is equation 1. Let's call this equation 2, equation 3, equation 4. We're going to transpose equation 1 to let G be the subject of the formula. We're also going to transpose equation 3 to let G be the subject of the formula. That we'll be able to use to eliminate G. You see? So, let's see. We transpose equation 1. It says AE plus BG equals 1. If we subtract AE from both sides, we have BG is equal to 1 minus AE. Okay, you can see that these are really simultaneous equations. You can't really use elimination because we don't have numbers here, it's just letters. Right? So, what we'll do is just go ahead and use transposition. We transpose these. Not going to attempt elimination here. Now, we want G. So, what we will have to do is divide both sides by B. So we have BG is equal to 1 minus AE. But when you divide by B on the left, we must divide by B on the right as well. So we cancel down, and we see that G is equal to 1 minus AE divided by B. You see that? Alright. So remember, this was equation 1. Now, that is G. The strategy that we're using is to make each equation such that G is the subject of each equation. That's a very nice strategy to use. So, equation 3 says CE plus DG equals 0. DG equals 0. We want to know what G is equal to. So if we, remember this is equation 3, if we subtract CE from both sides, we have DG equal, it's going to be 0 minus CE, so it's a negative CE. You see that? Nice. Then to get G, we divide by D. So we have DG equals negative CE. We divide here by D. D cancels itself, and we divide here by D. So what we have here is that G is equal to negative CE divided by D. Alright. Now, let's look at this. The fact is G is equal to G. You see that? G is equal to G. Now, if we have G equals to G, and G is 1 minus AE, and G is also equal to negative CE, then what we can see is that 1 minus AE divided by B, 1 minus AE divided by B must be equal to negative CE divided by D. You see that? So now, let us multiply both sides by D and also by B and see what's going to happen. If we multiply both sides by D, we'll have D multiplied by 1 minus AE is equal to, and this will be B multiplied by negative CE, so it's negative BCE. Remember, when we multiply both sides by D, D will cancel itself here, so we don't have a D on the right hand side. And when we multiply by B, B would cancel itself on the left hand side and multiply what is on the right. But we did not put in all of those writings. Now, here, expand the bracket. We would have D minus ADE. You see that? Equals minus BCE. We want to make E the subject of this equation. How about switching sides? So negative BCE comes on the left, equals to, on the right we have D minus ADE. It's saying the same thing. What I want to do is add negative ADE to both sides. You will have it come over here as ADE minus BCE equal. And the fact that we added this, I'm not going to write all the steps, but you could repeat this thing that I'm doing and write down all the steps. But this is equal to D. Now look at this. Suppose we factorize to make E come outside the bracket. We would have E here in the bracket. I would have AD minus BC equals D. Oh, look at this. AD minus BC. Where did we see that before? Oh, AD minus BC. Whoa, this is nice. We are seeing the determinant come out right here. But anyway, as I said, we want to make E the subject. So we see that E is equal to D divided by AD minus BC. So let's rewrite it up here. E is D over AD minus BC. So here, let's write it out here. E is equal to D divided by AD minus BC. Nice. Well, let's continue. We need to find F, G, and H as well. So, we're not going to crowd the board too much. So, let's erase some of what we have here and use the same space again. Alright. Let's erase this part. Now, here, we have found E. Let's find another letter. Remember, we're not interested in A, B, C, and D. They are just A, B, C, and D. What we want to find out is what is the inverse. And the inverse has in E, F, G, and H as the elements, so we need to find those. Now, let's see what happens here. If we look again at equation 1 and 3, equation 1 says AE plus BG is equal to 1. That's equation 1. Suppose we make E the subject of equation 1. Here, what we would have to do is subtract BG from both sides. So we'll have AE equals 1 minus BG. It will have subtracted itself on the left. Then we divide by A. Divide both sides by A, you will end up with E is equal to 1 minus BG divided by A. Alright. How about also writing down equation 3? Equation 3, CE plus DG equal 0. CE plus DG equals 0. Alright. Now, we also want to make E the subject of equation 3. So, if we subtract DG from both sides, we have CE is equal to negative DG. Then if we divide both sides by C, what we'll get is E equals negative DG divided by C. Now, here, E is equal to E. You see, E is equal to E. Therefore, this must be equal to this. So, let us write that down. 1 minus BG divided by A must be equal to negative DG divided by C. You see that? Whoa. I love this. Here now, we can put this together and then have the two G's beside each other and factor it out, and we could find out then what G is. So, if we multiply A by both sides, multiply both sides by A, then multiply both sides by C, we cross multiply. So, multiplying both sides by C, we have C multiplied by 1 minus BG equals, multiply both sides by A, we have negative ADG. Expand the bracket, multiplying C by each item in the bracket, we have C minus CBG. Let me write it as BCG to make it in alphabetical order. BCG equals negative ADG. Alright. Now, here, if we switch it around Or let's not switch it around this time. That's what we did last time. Let's do it without switching them. If we add ADG to both sides, what we will have? What we will get is C minus BCG plus ADG equals 0. See that? Then we subtract C from both sides. C will subtract itself over here. We would have BCG, many negative BCG plus ADG equals negative C. Let's put the ADG on the left of the negative BCG. We will have ADG minus BCG equals negative C. So that's what we have there. So now, if we factorize, we have G outside the bracket and we have AD inside the bracket minus BC equals negative C. Then if we divide both sides by AD minus BC, which you see is the determinant, we have G equals negative C divided by AD minus BC. So G is negative C over AD minus BC. So let's put it up here. G is negative C divided by AD minus BC. Alright. Negative C divided by AD minus BC. Now, let's do some erasing. Clean parts off the board and reuse it. We found two of the elements in the inverse so far. Now, what we found are E and G. Time to find F and H now. Now you notice equations 2 and 4, they have F and they have H. Suppose we transpose each to make H the subject. In equation 2, what we have is AF. AF plus BH equals 0. Subtract AF from both sides, we have BH is equal to negative AF. Divide both sides by B, we have H is equal to negative AF divided by H. Here by B, not H. So H is negative HF divided by B. That comes from equation 2. Let's look at equation 4 now. Equation 4 says CF plus DH equals 1. We want to transpose this for H as well. If we subtract CF from both sides, we have DH is equal to 1 minus CF. Divide both sides by D, and we have H is equal to 1 minus CF divided by D. So, there you have that. Now, since we have H being equal to H itself, but H is this and H is this, so these must also be equal to each other. So, negative AF divided by B must be equal to 1 minus CF divided by D. Alright, see that. So, if we multiply both sides by B, we're going to have negative AF, D would cancel itself, equals 1 minus CF, and B would multiply all of this, and it will be divided by D. You see that? This kind of looks like D. This is A. Now, if we multiply both sides by D will cancel itself. And what you would end up with here is ADF. Now, expand the bracket. We have negative ADF equals B minus BCF. Now, here, if we add BCF to both sides, we would have BCF, positive BCF, minus ADF equals B. Now, we have F outside a bracket, and we have BC minus AD inside the bracket equals B. We would have F is equal to, if we divide both sides by BC minus AD, we would have B divided by BC minus AD. But guess what? It is AD minus BC that we want. So what we can do is multiply this by negative 1, but we'd have to multiply the top by negative 1 as well. So we'd have negative B divided by, when we multiply negative 1 by negative AD, we get a positive AD. Then we multiply negative 1 by positive BC, we get a negative BC. So guess what? Look at it. Whoa. Really nice. It is negative B divided by AD minus BC. So F is negative B divided by that. So let's write F down here. F is equal to, what was it again? Negative B. So F is negative B divided by AD minus BC. You see that? Now, we have one more letter to find out what it is. That is H. We're now going to find H. We already found E, F, and G. Now we want to find out what H is. So, let's erase what we have down here to make space on the board. Now, you see, this is very interesting, very, very interesting. We look again at equations 2 and equation 4. Equation 2 says AF plus BH equals 0. What is it that we want to find? We want to find out what H is. What we will therefore do is look at both equation 2 and 4 and transpose each of them for F. Let F be equal to F, so therefore whatever F is saying it is equal to, and whatever else it looks different that F is equal to, both of them must be equal. So here, this is equation 2. Let's write up, let us subtract BH from both sides. So we have AF is equal to negative BH. When you divide both sides by A, you have F is equal to negative BH divided by F from A divided by A. Alright. Now, equation 4. Equation 4 says CF plus DH equals 1. Here now, we want F. So we subtract the H from both sides. So we have CF is equal to 1 minus DH. We divide by C, so F is equal to 1 minus DH all over C. So now, F is equal to F. Therefore, this is equal to this. Alright. So, what we have is that negative BH divided by A must be equal to 1 minus DH divided by C. We multiply both sides by A and also multiply both sides by C, which we call cross multiply. What we would have is negative BCH is equal to A times 1 minus DH. See that? So now we'd have negative BCH is equal to A minus DH, because A times 1 and A times DH. So now we add DH to both sides. It will come on the left hand side as DH, because we're adding it. Then your minus BCH equals, but negative DH plus DH is 0. So you only have A over here. So now, see, we have our two H's. We factorize with H outside the bracket. Then we have D minus BC. And you remember your factorization, right? Remember, if you don't remember it, you will have another video that you could check out. So here, what we have is, what we have here is A. I left out the A from before because A times DH would be ADH. So let's put the A here. It's ADH and the A will come here. So now, we divide both sides by AD minus BC and we get A over AD minus BC. That's H is equal to A divided by AD minus BC. So H is A over the determinant. H is equal to A divided by AD minus BC. Now, remember, we have our E, F, G, and H here. This was our original matrix, E, F, G, H. We find out what each letter represents. Let's write it inside the matrix. E is equal to D divided by AD minus BC. F is negative B divided by AD minus BC. Remember, let me just do this part here. We have the matrix that we want to find out, which is the inverse that we want. It is E, F, G, H. Alright? But now we know that E is D divided by AD minus BC. So here we write D divided by AD minus BC. You see it here? F is minus B divided by AD minus BC. As for G, G is negative C divided by AD minus BC. And then H is equal to A divided by AD minus BC. Now, you remember that when we multiply a matrix by a number, each element in the matrix is multiplied by that number. Now, this matrix that we have here would be similar to saying that this is D multiplied by 1 over AD minus BC. The B here, this part would be negative B multiplied by 1 divided by AD minus BC. Remember that? When you divide by a number, it's the same as multiplying by 1 over the number. This C minus C here over AD minus BC is really minus C multiplied by 1 over AD minus BC. And then here, A over AD minus BC is the same as A multiplied by 1 over AD minus BC. So you see that. Now, what happened just before we multiplied each element in the matrix by that number? That number is 1 over AD minus BC. You can see it here. It would have been outside the bracket, so we really are factoring it out. It's a common factor there. So what we have is 1 divided by AD minus BC multiplied by D comes up here. This here is negative B, is negative C, and this is A. Aha! There you have it. What we have is the inverse of the matrix. So therefore, A, B, C, D, inverse. Let me write that again. Inverse is equal to 1 over AD minus BC times A minus B minus C D. Oh, D, I mean, I wrote it making it look like A. What is D? D minus B minus C A. The augmented matrix. We interchange A and D. So D, A comes down here. D comes up here. We change the sign of B and C. So, there we are. Very well done. And I enjoyed this proof, and I know you enjoyed it too. Whoa, this is lovely. This is the kind of one of those things that I like, right? I was excited about doing it, and this is really a nice proof to do. You can have fun and redo it and review the video. Now we see where the matrix inverse comes from. Lovely. Alright, so I will see you in the next video.